This learning target is going to talk about the vertex form of a function. Last learning target, we talked about the parent form, where every parabola started at 0, 0. Well, not every parabola or quadratic is going to start at 0, 0. So we're going to talk about what happens when these graphs shift around the grid. So we're going to add this new numeral to our equation. We're going to say x squared plus a number. And we're going to see what happens when we add that number to our parabola. So I'm first going to draw the parent function. Remember, we're going to memorize how to draw this on the graph. We go start at 0, 0, over 1 up 1, over 2 up 4, over 3 up 9, and then the same thing on the other side. This is the parent function that we worked with in the last learning target. So I'm just going to graph that onto this grid. When I graph the parent function and I have something added to the end of it, all that means that I have to do is start at the vertex right here and move that up however many it is. In this case, it's plus 4, so I'm going to go 1, 2, 3, 4, make my new vertex here, and then I'm going to go over 1 up 1, over 2 up 4, 1, 2, 3, 4, and those are my new points for my parabola. All I did was shift this graph up 4. And if I want to double check that onto my calculator or Desmos, whichever you prefer, I can go ahead and graph x squared plus 4. I can also graph x squared in the same grid. And you can see that it's going to graph two parabolas, and x squared plus 4 is just shifted 4 up from the parent function. The same thing happens if I go ahead and subtract a number from the x squared. So I'm going to go ahead and draw the parent function again. Over 1, up 1, over 2, up 4. So there's my parent function. And then minus 7 is just going to go down 7 from the vertex of the parent function. So start at the vertex, go down 7, 1, 2, 3, 4, 5, 6, 7. There's my new vertex, and now just go over 1, up 1, over 2, up 4, and then you have your new graph. You don't need to make a table, you don't need to plot points. If you want to plot points and make a table just to double check, you totally can. You can go to your graphing calculator, hit second, hit table, and it'll give you all the points that you need to graph. But I'd really like you guys to memorize it's just a shift up and down if you're adding or subtracting a number after the x squared. And that's called a vertical move. We move that vertically means up and down. There's another way we can move our parabola, and that's left and right. We call that a horizontal shift. Now this one looks really weird because the horizontal shift is actually occurring inside a set of parentheses, and then the squared is on the outside. This is going to be a horizontal shift. So I'm going to start again by graphing the parent function. You don't have to do this every time. I'm showing it to you so you can see how it moves. So there's my vertex, over 1 up 1, over 2 up 4, over 3 up 9. There's my parent function. So I'm going to graph that first. All right, draw your parent function. And now notice I'm going to put this in the calculator to show you how this moves. So I'm going to go back to y equals. I'm going to clear out my other shift. So I'm going to put in parentheses x minus 3, parentheses, and then squared. And when I graph it, it's going to graph it, and look how it moves. There's my parent function right here, and then see how it moved to the right 3. So I'm going to go ahead and move my vertex to the right 3. 1, 2, 3. And I'm going to do my over 1 up 1, over 2 up 4 from there. Now the weird part about this is that you've got this minus 3, but that minus sign indicates a movement to the right. Even though it's minus, I know when you think minus, you think left, but it's the opposite when it's put inside parentheses. So that's a right movement. On the other hand, if I have a plus 3 on the inside, what do you think that's going to indicate? It's going to indicate a movement left. So I'm going to go ahead and draw my parent function. There's my original. And the more you draw this parent function and really think about it, the more you'll memorize it. Now again, like I said, you don't have to draw this every time. I'm just showing it to you to help you. So I'm going to go to my graphing calculator. I'm going to show you that when I change this minus sign to a plus sign, now you're going to see that the graph all of a sudden moves to the left. So I'm going to go ahead and plot my vertex, move it to the left. So there's my original vertex right here. I'm going to move to the left 3, 1, 2, 3. And I'm going to go ahead and plot my new parabola. Over 1, up 1, over 1, up 1, over 2, up 4, 2, 4. And my parabola just moved to the left 4. That is a horizontal shift. That moves left to right. So the main core learning of this target is being able to notice what's in the parentheses and what's outside the parentheses, and being able to move that parabola around the grid without having to make a table and saving you some time. So this is called vertex form when we put it all together. So y equals, this is our formula, there might be a number in front of your equation, that's a. That's just like before when we had like y equals 2x squared. In the previous learning target, that was our a. Remember that a stretches or shrinks the graph, and its sign determines whether it's concave up or down, so that doesn't change. What will change is what we just talked about, where we have like a number inside. That is a shift left and right. And then if we have a number on the outside, this plus a number here, that is a shift up and down. So when we put this all together, it makes a really cool equation that can help us get a lot of information without actually having to graph anything. So when I look at this first equation, y equals 1/2 x plus 4, this right here, that is my a value, that negative 1/2. The negative, this minus sign right here, tells me that that's concave down. The 1/2 tells me that that is going to be a shrink. We learned that in the last learning target. And now I'm going to take a look and see what my vertex is going to be. Now to define the vertex, remember, this is going to be a shift left 4. So that's my x value. So my vertex is going to be negative 4. Change the sign in the parentheses. And notice that I've got nothing over here. So that's like saying an invisible plus 0. So that's negative 4, 0. So when you want to pull your vertex out of it, this is your a value here, and this is your y value here. Okay, and that's kind of what this is saying right here. It's h comma k is your vertex. The next one, take a look at see how there's nothing right here in front? That means that a equals 1. If a equals 1, then that's going to be concave up because that's a positive value. And if a equals 1, that's going to be a stretch because it's greater than 0. I mean, sorry, it's greater than or equal to 1, so that's going to be a stretch. The vertex then, I'm going to get from these two values. My x value is going to be negative 3 because it's moving to the left 3. And then my y value is going to be this minus 1 because that's going to move down 1. So there's my vertex. So you should be able to get all of this information just by looking at the equation of vertex form. If you'd like to pause the video and try and do these next two on your own, figure out whether it's concave up, stretch, shrink, or none, and label the vertex, that's a good idea, and then unpause and see the answer. If not, you don't have to. You can follow along with me, but it's always good to check your understanding. Okay, so concave up, concave down. This is a negative in front, so that's going to be concave down. I don't have a fraction here, so that means it's going to be a stretch. And my vertex comes from that number in the parentheses, number outside. Number inside the parentheses is plus 1. That is a shift to the left 1, so that's negative 1. And then that number on the outside is a plus 4, so my vertex is 4 going up. The next one, I've got a negative 4. That means it's concave down because it's negative. The 4 makes it a stretch. And my vertex, my number on the inside is negative 4, so that becomes a movement to the right 4, so that becomes positive. And then my number on the outside is negative 4, so that's a movement down 4 to give me a negative 4 for the y. Okay. So let's put this all together and be able to try and graph this without using our calculator. So I've got my quadratic function right here. I'm using this function notation. You've seen this before in the last learning target. Remember, this function notation means the same thing as like saying y equals. It means the same thing. It's just basically defining this graph. We're going to call it g. Okay, so we're going to identify the vertex we're going to identify the vertex first. So the vertex is that +1 on the inside, so that's a -1 for my movement left. And on the outside, I've got the -2. So -1, -2 is my vertex, and I'm going to go ahead and plot that on here. So -1, -2, there's my vertex on the graph. So that's where my graph is going to have its turning point. This graph, I can also determine that it is concave down because it's a negative in front, and I can also determine that it's going to be a stretch because it's got that 3 in front. The axis of symmetry, we talked about that last learning target. The axis of symmetry is that invisible line that goes through the middle here. Okay, I'm drawing it in, but normally it's invisible, and it's always the equation x equals and whatever number it's going through. In this case, it's going through -1, so my axis of symmetry is -1. Now the question is, how do I find more points for this parabola? Well, I know my vertex is -1, -2, so I'm going to use a table to help me. I'm going to make a table, and I'm going to put the vertex in this middle spot. So my x value is -1, y is -2. Now remember how we talked about there should be a mirror effect, meaning whatever numbers I have on that side should be the same as the numbers I have on the other side. To get those numbers, we're going to go ahead and plug this into our calculator or into Desmos, whichever you want. In fact, I can show you on Desmos how this works because we did figure out that there was a table. So we're going to go to Desmos here. I'm going to get my keyboard. So Desmos here. And this is if you don't have a graphing calculator, you can use this. Okay, so there's my line. What's the equation I'm graphing again? I'm graphing, I want this move. Okay, so my equation is -3 parentheses x plus 1. So I'm going to type in here -3 parentheses x plus 1. And then I'm going to put my squared above it. And then it's going to be -2. So -2. So there's my graph. I can see it graphed there. Now, what I really want from this graph is a table because it's much easier to see points from a table. So if you hit this little gear right here and then hit this little table button, it's going to suddenly give you a table of values. Okay. Now, I know that my vertex is at -1, -2, -2. So that's my middle point. So the numbers on the outside of it, I'm going to go ahead and label here. So I'm going to go ahead and put a -2 and a -3 here and a 0 and a 1 here. So now see how the x values are in chronological order? And now when I go back to Desmos, I'm just going to see what those matching values are. So with -2, it matches a -5. With 0, it's -5. And with 1, it's -14. I don't know if I can scroll up to find more, but since I know this is a mirror, I know that this has to also be -14. So that's how you can find your points in a table using Desmos. It's pretty cool. That's if you don't have a calculator. So now that I know these points, now I can plot them. I've got -2, -5, so that's that point right there. And -3, -14 is this point down here. Now, since it's a mirror, I know that my points are going to just be the same way across the axis of symmetry here, so I know I've got a point right here. And additionally, I know I've got a point right here because they reflect each other across the axis, and then I can just connect my points. I mean, that's supposed to like go through there. I didn't draw that very well. Okay, so that's my parabola. It's concave down. It is a stretch. I have my 5 points to plot my graph. You always need at least 5 points every time that you do this. If you do something like this, and I'm going to erase this for just a second. If you do something like this and plot your point and then just go like this, that is 100% wrong. You need at least 5 points. Don't do that. Okay, and for the last example, if you want to try this one on your own, you totally can. You can always pause and try on your own. But I'm going to show this one using the graphing calculator instead of Desmos. So first I'm going to get all my information here. So I know that this graph is going to be concave up because that 2 is positive. I also know this is going to be a stretch as well because that 2 is greater than 1. And now for my vertex, I get my x value from this number, change the sign because that's a movement right. And then I get my y value from this number, That's -7. That's a movement down. I'm going to go ahead and plot that point. Now this grid, 1, -7, so that's right here. I'm going to notice that my axis of symmetry is this invisible dotted line that goes through here. You don't have to draw this in every time. I just draw it in to help me see my mirror, so you can leave that off if you like. But your axis of symmetry is going through +1, so that's x equals 1. I'm going to go ahead and put my vertex in the middle of this table here to show that that's where the mirror occurs, around the vertex. And I'm going to go to my graphing calculator, go to my plots and clear these out. And now I'm going to type it in just like I see it. 2 parentheses x minus 1 parentheses, the squared goes on the outside, and then -7. Going to hit graph. It's going to show me a picture of the graph, but I really want that table. So I'm going to hit second and then graph again, and I get that table. And then I'm going to scroll to this vertex point, 1, -7. So I'm going to go down to 1, -7. There it is. I'm highlighting it right here. And notice that I'm going to plot these points on the outside of it. So this is going to be 0, 1, -1, and then 2 and 3 here. And then just look at what y values match. So that's 0, -5, -1, 1, 2, -5, and 3, 1. And notice I've got my mirror. I've got the same numbers on either side of the -7. And now I can go ahead and plot those points. So 0, -5, -1, 1, 2, -5, and 3, 1. And I've got my 5 points for my parabola. Okay, so that's vertex form. You should be able to get all this information looking at the equation, and you should be able to graph with the use of your Desmos or your graphing calculator. Okay, good luck.